Alright, this video is for graphing lines from standard form. Okay, so standard form is written as Ax plus By plus C equals 0, where A is always positive. Okay, so A has to be positive, and A, B, and C are all integers. Okay, so whole numbers, positive or negative. Okay, so they're all integers. Okay, so whole numbers, positive and negative. All right, so to graph from standard form, okay, you can use 1, the x and y intercepts, 2, x-intercept and slope, 3, the y-intercept and slope, or 4, any point on the line and the slope. Okay? So in this form, if you can get the x and y-intercepts and they're nice whole numbers or easy fractions to plot, then fine. So the x and y-intercepts, those are the points on the graph where the line crosses the x and y axis. So that's the x-intercept there. Okay, x-intercept. And that's the y-intercept. Okay, so to find the x-intercept, well, for this, you know that y equals 0. So at this point here, the x-intercept, you know that the coordinates of that are going to be something x and 0 for the y. So you know that y equals 0 at the x-intercept. So if y equals 0, just sub y equal to 0 into the equation, and that piece goes away. And then you can just solve that equation. Okay? And this is basically what it's showing here, is that the intercepts, so at the y-intercept, the x-coordinate is 0. At the x-intercept, the y-coordinate is 0. Okay? So that's if you want to find the two intercepts. Let the other coordinate equal 0. Plot them, draw the line through it. For methods 2 and 3, so 2 and 3 have here that the x-intercept you're using and the slope, or the y-intercept and the slope. Okay? So if one of the intercepts are fractions, okay, so it's not as easy to plot, or decimal or something, and you may just not get nice points, so you may have to just do the best you can. But if one of them is a fraction and the other one is not, then find the slope by putting it into slope-intercept form. So you just rearrange the equation. You'll see that in the examples. And use the intercept that is not a fraction. Okay, so say you've got something like this. You've got the x-intercept, you know, is 3, and the y-intercept is something like 7/9. Well, it doesn't really work very well. Or 9/7. It's hard to plot. Okay? You can get it approximately, but not exactly. But if you know the slope was negative 3/2, then you could rise -3 and run 2 and get the second point. So if you have any point and the slope, you can draw the line. Okay? So if you have an intercept, use that as your starting point, and then find the slope by converting to slope-intercept form using algebra, and then use the slope to get a second point and draw the line. Method 4, if both intercepts are fractions, then convert the equation to slope-intercept form and try to determine a point that has integer coordinates. So maybe for this one, you've got a y-intercept that is not nice, and an x-intercept that is not nice. It's not nice integer numbers. But you know that the point, say, 3, 2, is on the line. you know that, those values satisfy the equation. Okay, and you'll see this in an example. And if it does, then you can use that point as your starting point. And then you can use the slope. Say the slope is -4/3. So you then go down 4 and over 3 from that point, and you get a second point, and you could draw the line. Okay, so if m equals -4/3, go down 4 and over 3, and you get the second point. So it doesn't matter what point you have as your starting point on the line, you need one point, and then the slope will give you another point, you can draw the line. Okay, so only the first method here allows you not to change the slope-intercept form, and that's if you've got two clear intercepts, an x-intercept and a y-intercept. So let's look at some examples here. Okay. So the first example, okay, so 3x plus 2y plus 12 equals 0. This one's nice because 3 divides into 12 and 2 divides into 12. Okay, so you're going to find the x-intercept. So at the x-intercept, y equals 0. When you plug y equal to 0 in there, that piece goes away. Okay, so that just goes away. 2 times 0 is nothing. So 3x plus 12 equals 0. Now you're just solving a two-step equation. Subtract 12 from both sides, divide by 3, and you got x equal to -4 is the x-intercept. Okay, the y-intercept. Well, sub x equal to 0 in. So 3 times 0, 0, 2 plus 2y plus 12, 2y plus 12, solve that as a two-step equation, so subtract 12 from both sides, divide by 2, and you got a y-intercept of -6. Okay. So now we got an x-intercept of -4, a y-intercept of -6. Put this on the graph. X-intercept of -4, y-intercept of -6. Draw the line through it. Okay, you just need 2 points to draw a line. Now, just to check here for this one, you don't need to do this, but converting this to slope-intercept form. I need y equals mx plus b, so I need to isolate the y and solve for it. So I'm going to subtract 3x and 12 from both sides, okay, because I want the y alone. Then I'll have 2y equals -3x minus 12. Now divide both sides by 2, the whole side, so not just the 3 or the 12, but both of them. Okay, so 2y over 2 is just y. And then the -3 divided by 2 is the slope. And -12 divided by 2, which is 6, is the y-intercept. Let's check that. The y-intercept is 6. We checked that before. And the slope, if you just take 2 clear points, here's one here, here's one here. So you rise -3, run 2, that works. Okay, so that is the line. For the next one, we've got x plus 3y minus 2 equals 0. You can check right away. If the coefficient of this does not divide evenly into this, you're not going to get a nice intercept for that one. Okay? So you're not going to get a nice x-intercept. Well, actually, you are going to get a nice x-intercept. You're not going to get a nice y-intercept. Okay? So the x-intercept, when y equals 0, plug y equal to 0 in there, solve, and you get x equal to 2. That's a nice number. Okay, we can use that. The y-intercept at x equal to 0, okay, plug x equal to 0 in, you get 3y minus 2 equals 0, add 2 to both sides, divide by 3, and you get the y-intercept is 2/3. That's kind of hard to plot. Okay, so we're going to now convert it to slope-intercept form. Okay, so subtract x from both sides, add 2 to both sides so that we can isolate the y. We get 3y equals -x plus 2. Divide both sides by 3. So that -x is -1x. So it becomes negative 1/3 x plus 2/3. Okay, 2/3 is the y-intercept, that's correct. But now we've got the slope and the x-intercept, and we can graph this line. So let's look at it. So we got the x-intercept is 2, that's what we calculated, and the slope is negative 1/3. So I'm going to rise negative 1, run 3, and I got a second point. Or I can rise 1 and run negative 3, and I got another point. You can check it that way too. Okay. So that's that one. Here's one here that is 3x minus 2y plus 4 equals 0. Okay. Finding the x and y intercepts, so you're setting the opposite equal to 0. And when you find the y-intercept, it's nice, it's 2. But the x-intercept, not as nice, it's negative 4/3. Hard to plot. Okay? Hard to plot exactly. Okay, so we're going to convert it to slope-intercept form. This time I'm going to add 2y to both sides because it's negative in front of the 2y, so I'm going to keep it positive. Add 2y to both sides. You've now got this, and you can divide both sides by 2. When you do that, you get y equals 3/2 x plus 2. Writing it this way, we can see the slope. The y-intercept is 2 as we've calculated. Okay, and now you're going to graph it. So from the y-intercept, as we've normally done, from slope-intercept form, plot it. Then use the slope. Okay, so run 2, rise 3, or you can rose 3, run 2, get the second point, graph it, or run negative 2, rise negative 3, gives you the same thing. Okay, negative divided by a negative is a positive. Okay, so that's that graph. Next example, 5x minus 2y minus 9 equals 0. Okay, try to find the intercepts for this. Okay, you might want to pause the video and try to do it, and then check back in. Okay, so when you're doing this, you're just solving the equation. You get x equal to 9/5. It's not very nice. This one, not as bad. X equal to negative 9/2, which is negative 4.5. It's okay to plot. You can probably approximate that. But if you didn't want to, then you convert the whole thing to slope-intercept form. Okay, so I'm going to add 2y to both sides again. Okay. So now we've got the slope as 5/2. The y-intercept is negative 9/2, which we already know. And you can plot that. So what I did here was I plotted negative 4/5, or sorry, negative 4.5, and then I rose 5, that's the slope, and run 2, and I got another point. Okay, so that'll get you the line. Or you could try to find a point on that line. So if you check, 1 comma negative 2 satisfies the equation. So this takes some playing around to try and get integer values here in this equation. So 1 comma negative 2. If you go back to the equation, 5 times 1 is 5, minus 2 times negative 2. 2 times negative 2 is going to be negative, so minus a negative 4 is plus 4. 5 plus 4 is 9. Minus 9 is 0. Okay? So you can check that this point here actually satisfies that equation. Okay? So you could use the slope from that point. So we'll go to the point 1 comma negative 2. So I go 1 comma negative 2, there it is. I run 2, rise 5, and I got another point, and that works to get the line too. Okay. A couple other examples here. I'm just going to show them to you. This is for horizontal and vertical line. Okay, so horizontal, you can check out the work on it. Okay. And vertical, so you might want to pause the video so you can check this out. So it's a vertical line. Okay. And that's it for that one.